Hello friends, today we will go through the friction topic and we will deal an important friction problem. And our problem is a block of weight W1 equals to 1800 Newton rests on a horizontal surface and supports on the top another block of weight W2 equals to 1000 Newton as shown in the figure. Find the magnitude of force P to slide the lower block, assuming the coefficient of friction for a surface is 0.40. So friends, our problem is we need to find this force P that is required for moving the lower block, that is W1 equals to 1800 Newton. Okay, so this is our problem and let us see the solutions. Now friends, we shall draw the free body diagram of this weight 2. So we shall draw the free body diagram of body 2 that is having weight equals to 1000 Newton. So this weight W2 shall be acting as shown in the figure, where W2 is the weight of this body acting vertically downward and R2 is the reaction that is acting along these directions. And furthermore, there is the string that is acting from weight W2, isn't it? So there shall come the tension along that string. So let us assume that the tension acting along the string be T, and if we draw this line, then this line will be 30 degrees. So angle made by the string with the horizontal is written as 30 degrees. Now friends, we shall proceed the solutions after drawing the free body diagram. Okay, so we shall consider the free body diagram as shown in the figure. Now we shall use the equilibrium conditions or equilibrium equations. So firstly, we will consider the summation of forces in x direction equals to 0, and taking the rightward direction as positive, we will get T cos 30 degree equals to F2. Here F2 is the friction force that is occurring in this body, isn't it? Since it is acting along since this string is acting along this direction, so there will be the friction force that is coming in between the weight W2 and W1, so along in this direction. So if we we will just put the value of F2 as mu into R2, isn't it? And we have the value of coefficient of friction as 0.40, and if we have to substitute all these things, isn't it? So R2 will be coming out to be T cos 30 degree by mu. So let it be equation 1. Likewise, we can just write the equilibrium equations in y direction, that is summation of y equals to 0. Taking upward direction positive, we will get R2 is along y direction plus T sin 30 degree equals to W2. Now we can easily substitute the value of R2 as T cos 30 degree by mu in this equation, and all the remaining values are known here, so we can easily solve this in order to get the value of tension. So tension come out to be 375.22 newtons. So if you substitute the value of tension in expression 1 or equation 1, you can easily get the reaction to R2. So R2 will be coming out to be 812.275 newtons. Now friends, we shall draw the free body diagram of W1, and we will see the effect that is caused by this W2 in the weight W1, isn't it? Now we shall just see it out. So this is W1, this body is W1, isn't it? So its weight is acting vertically downward and its reaction is just passing from the center of gravity. So R1 will be the normal reaction of weight W1, isn't it? And we shall be careful here that this weight W2 is also exerting certain reactions or passing certain reactions in the weight W1. Here this body W2 is exerting a reaction equals to R2 in the downward directions, isn't it? Since we have just drawn the free body diagram of this weight W2, and this weight and for the weight W2, this weight is acting from the centroid, and this is the normal reaction, and in order to balance this, we need to apply a reaction in downward directions. So Again, we shall also look that this force P is sliding the weight W1. So the friction in this surface shall be acting along these directions. So we are assuming that friction is F1 acting along the contact surface. Now we shall also be careful in this case that if we are moving the lower block, then the certain portion of friction will be acting along this contact surface as well. Let us suppose that this friction is acting along these directions and its magnitude be F2, since friction always act on the opposite directions of the applied force, isn't it? So we have assumed that F2 is the friction that is occurring between the W2 and W1 surface, contact surface, isn't it? So this is the free body diagram, and we have watched the effect of W2 on W1. Now we shall consider the equilibrium conditions or equilibrium equations in order to find the magnitude of force P for sliding the weight W1. So let us consider the summation of forces equals to 0, taking rightward direction as positive. So then we can easily get P equals to F1 plus F2, and if we substitute the value of F1 as mu R1 and F2 as mu R2, then you will get this expression. Okay, likewise if you just do the summation of forces in y direction taking upward direction positive, you will get R1 equals to W1 plus R2, isn't it? So from second we can easily write P equals to mu R1 plus R2, and if you substitute all these things, then you will be getting the value of force P as 1369.90 newtons. So friends, this is the way we can just solve the problem associated with the frictions, and this type of problem is very important in university level examinations. So watch the complete video.